So I'm going to start off this section on input and output, I/O, in Java with an introduction to exceptions. And the reason for that is many of the methods that we'll be using to read and write files actually require that exceptions are handled. Now there's two main approaches to dealing with errors when programming, and they're often referred to as LBYL and EAFP. And what that stands for is look before you leap and easy to ask for forgiveness than permission. So in Java, it's more common to look before you leap, and we've seen this a lot when we test that an object is not null before we attempt to use it, for example. Now the other approach, the EAFP, easy to ask for forgiveness and permission, is to go ahead and perform the operation, then respond to an exception if something goes wrong. So trapping and handling exceptions is pretty simple. The code that may cause a problem is wrapped in a try block, and then catch is used to deal with the exception. Now there is a bit more to it than that, things like deciding which exceptions to catch, things of that nature, but I'm going to start going through a couple of examples to demonstrate both approaches to dealing with errors, and as a result of this show how exception handling is used. So I've created a new project, let's go ahead and make a start on it, and we're going to demonstrate both approaches using functions to perform integer division. So I've got my main method here. I need to write a couple of methods first. So first one's going to be private static int divide LBYL. So that's the look before you leap scenario. So we're going to pass two integers into x and y, and looking before we leap, we're actually testing to see whether y is not equal to 0 before we actually do any processing. So if y is not equal to 0, then we can return x divided by y, else we're going to return 0. So that's the look before you leap. We're actually testing the conditions are valid, because of course you can't divide something by 0. You'll actually get an error if you do that. So we're testing to make sure that the value that we're dividing by, in this case y, isn't 0 before we actually do the test. So that's the look before you leap. Now the other way is to basically easy to ask for forgiveness and permission. So we're actually going to just do it a different way. So we're going to do private static int divide EAFP, easy to ask for forgiveness than permission, and that's going to be int x, int y, so same parameters, but in this case we use a try block. So we type try, left brace, and then we put return x divided by y. So we're not doing any testing there to see whether the values are correct. And then we need to do a catch. So we put catch. And the error we're going to catch in this case is arithmetic exception, E, like so. And then we just put return 0. So now that we've written our two methods, we need to call them from our main method. So we just put int x equals 98. So we'll just define some values. Int y, we're going to raise the error by making it 0. And if we do a system out print line for the look before you leap method, passing x, y, and then we'll do it with the easy to ask for forgiveness and permission error method rather. So it's going to be divide x, y. So if we run both cases, or we run in both cases, you can see we obviously got 0 as a result in both scenarios. So in other words, both functions can cope with an attempt to divide by 0. The LBYL method checks first, as I mentioned, this is on line 13, returns 0 if y is 0, whereas the EAFP method attempts the division and catches the exception that is raised if dividing by 0. Now if we didn't make any attempt to cater for the possible error, the program would crash, and we can see that by adding another function. So we put a third function, which is private static int divide int x, int y, just to confirm it does actually crash, and we'll just won't do any checking, and we'll actually won't add a try block either. So we'll just return x, y, x divided by y I should say, and then if we output it, so it's going to be just divide x, y. So we should find that third method call will actually crash. And there we go, we've actually got it to crash. Arithmetic exception, divide by 0. So there's a lot of debate that is still going on about which method is better, but the simple answer is that really they're both better. because each approach has got its own advantages that are more suited to certain situations. Now, when using Java, it's more common to check first, but something is far easier to just try it and see. So in that example, there's very little difference in the complexity of the two methods, and you can probably have a good guess at what's going on just by reading the code. Now, for a slightly less contrived example, let's have a go at getting a number from a keyboard. Now, what we've done is we've used a scanner quite a lot so far in this course, but one thing we haven't done yet is to make sure that the values entered are actually valid. So this short program attempts to read a value from the keyboard and store it in an int variable. So first we'll try without making any attempt to handle invalid input at all. So I'm going to close it down, and I'm just going to comment these out for now. Comment that code out. Instead, what I'm going to do is I'm going to put int x equals get int. We're about to write that function, that method, and we're going to just output it. X is plus x. So let's write that function now. So it's going to be private static int get int, and scanner s equals new scanner, and it's going to be system.in, of course, which we've always done in this course, system.in, and we're just going to return s.nextInt to return the next integer or the integer that's been typed. So if we run this, and it's waiting for input, we didn't put a message on the screen to ask what we're wanting the user to type, but in this case we'll just enter a number like 45, x is 45. So that works okay, no problems. But if we change this and run it and put in Tim was here, we get an exception, input mismatch exception. You can see that showing there at the top. And the attempt to use nextInt on invalid input results is the reason that we're actually getting that error, and that's because the program doesn't handle the exception. So to cope with that, we can read the input into a string instead, and then check each character in the string to make sure they're all digits before attempting to parse the input into an integer. So we're going to create a getInt lbyl method and call that on line 13 instead. So let's close that down and let's write this method. Down here we'll put private static int getInt, look before you leap, lbyl, and let's rewrite it. So it's going to be scanner s equals new scanner system.in, and boolean is valid is equal to true. Then we'll print out a message this time letting the user know what we want. So please enter an integer. String input equals s.next, so we're going to capture a string, and then we're going to put for int I equals 0, I less than input.length. So we're going to go through the entire string that's been accepted from the keyboard. Then on the next line we're going to check to see whether it's valid. So if not character is digit, so is the digit at a specified position, and position will be input.char@I. So basically for each element in the string, each character we're testing to make sure it's actually a number. And if we find one that isn't, so we've got the not there, if not character dot is digit, we're setting is valid to false, and we're breaking out of the loop. And then if we got a valid answer, if the answer was valid, in other words, we've checked that all the digits were there, we can return integer.parseInt. We know that that's going to work now. It's not going to come up with an error because we've determined that they're all digits. We can return it that way. And if it wasn't valid, it's going to fall out of that condition. We're going to return 0. So now if we just test that this actually works, and we'll put get int lbyl, run that, enter an integer, so we can put something like 565, x is 565. That still works, but of course the other example did as well. And changing this to Tim, x is 0. So you can see what's happened there. We've basically gone through and checked to see that there are digits throughout the entire string that we've retrieved from the scanner. And if there was one that wasn't a digit. So in other words, it's going to be an invalid number. We're just returning 0. So you can see that, I mean, that's just one way of doing it, but there's quite a bit of code there to actually confirm that that was, you know, the input was invalid. So quite a bit of code to add. So we can write using an exception handler, probably a lot less code. So we can do something along these lines. Private static int get int EAFP, and that's going to be scanner s equals new scanner, and it'll be system.in. Then we're going to put same thing, asking the user to type a number. So please enter an integer, like so, and then we can just put a try. Let's try doing it by capturing any errors. Then we put return.s.nextInt and catch input match exception e return 0. So you can see that already we haven't run the code yet, but there's a lot less code in the getInt EAFP method than there is to the getInt LBYL. And just to be clear here with the try catch, I think you've probably got the hang of this now anyway, but when we do a try, if there isn't an error, the code that is in between the try block, or this try block, this code in here, any code that's in that block is executed if it's successful. So it'll continue executing. You could process many lines of code if you wanted to there, but so long as there's no exception that's raised, the code's going to continue processing, and then it will bypass the catch and fall through to the next line. But if there is an error, if an exception is raised, processing stops immediately and goes to whatever the code is in the catch block. So in this case, it's just going to return 0. So let's just run that and just confirm that it does work. Get into EAFP. So if we run that, same deal, enter a number, that's still valid, but an invalid number, Fred, X is 0. So you can see that there are scenarios, depending on what you're trying to achieve, where it can be more efficient. I think, well, certainly we can't dispute the fact there's less code in the getInt EAFP method compared to the getInt LBYL. I think it's a little bit more elegant as well, because you can look at that very quickly once you understand what exceptions are and know straight away, okay, input match, mismatch exception. We're trying to prevent that error from being captured, and you can see it's returning 0 if there's a problem. So it does really depend on what you're trying to do, because it's not always black and white to always use the EAFP approach or always use the LBYL approach. It really does depend on what you're trying to achieve. So contrasting the fact that this EAFP method, the getInt EAFP was a lot more efficient compared to the getInt LBYL. The reverse can sometimes be true as well. Like for example, what probably wouldn't make sense to use a try-catch block when checking rather that a key exists in a map, for example. In that scenario, it's probably going to be a lot quicker to use, the alternate method, which is the LBYL approach. You could obviously use it with exceptions, but checking for the existence of a key first, or using the map.get method is what I'm getting at, and checking that the value returned is a null before attempting to use it is going to result in more readable code. So in other words, there's less code. So it really does depend on what you're trying to achieve and the actual solution as to which approach you actually use. All right, so I'm going to finish this video here now. In the next video, we're going to continue on and we're going to start looking at some other types of exceptions and actually clarify exactly what an exception is and talk about runtime exceptions and general exceptions and the like. So, as always, see you in the next video.